Alright, so it's Alex Bodsky, the Chem243 final project, the Acebutolol synthesis attempt. So this was pretty interesting to me because I'm taking medicine pretty similar to this, so the names stood out to me on the list of molecules we were able to synthesize for the final project. Anyway, let's get right into this. So we had to start with benzene, right? So my initial thoughts were to start with adding this carbonyl group over here with the NH. And so you can see right here where I started to do that. So I added the HNO3 and H2SO4 to get the NO2 onto there, and then we reduce that to the NH2, sorry. And then from there we can pretty easily add this group right onto the end there. But I was a little confused as to where to go after that, so especially as to where to add this guy, the other C double bond O. And so I decided it would actually be easier if we added that one first, and then the meta-directing group of the HNO3 would actually end up over here. And then you can see it would be actually easier to end up with this. So that was the ultimately the pathway I went for that guy. So right here I have 2/3 of the functional groups on this benzene. And the last one I have to do is probably the most complicated one. Unfortunately, I had some advice on how to do it, but for now I can show you where I started and what did not work. So I wanted to create this with right here, this ester, and then an OH, and then this let me see what it was called, the isopropyl amine at the end there. So my initial thoughts were actually quite interesting. I wanted to use the organocopper or mechanism to attach this at the end, but I realized that wouldn't actually work in the end, because I would have created a symmetrical molecule, right, with this on both sides, and then in theory attach that to a Cl up there, but that was not going to happen. And I had some other ideas too, just on the general synthesis of the molecule, like for instance creating a grignard here to attach these together, and I thought that all of this would work, and of course if we were creating one large molecule to attach to the benzene, but that ultimately did not happen. And now I can lead you through the final synthesis, where we start with just a benzene ring, we add this with a AlCl3, so it's pretty straightforward so far. This is what I outlined in the very first part, and then the NO3 and H2SO4 adds that there, which is the meta addition. We reduce that to the NH2 with the lead and carbon. And then we actually have to create this other one. So with butyronitrile, which is around $70 per 100 mils, and we can pretty easily make this carboxylic acid right here, and then once we take off this OH with a Cl, we can add that right to the end there with two equivalents of this, and we get this molecule right here. And so now it's just adding the last part, and I got some tips on creating this sort of structure onto it with the ester and then the two Cl's double bond in between, so I can add the OH and the isopropyl amine to this. So that's what I'm going to do right here. So I have this structure we synthesized earlier, obviously. Then I add the chlorine right there onto this open point, and it may not actually go here. I'm not entirely sure where it would add. I think it would be one of these, so we may have to run this multiple times and to get the desired product, but regardless, we have the Cl right here. We can take that off and replace with an OH. And then from there, we can use NaOH, and then this molecule we're going to create down here, which is Cl. Whoops. I forgot to make that, sorry. Which is this Cl with an alkyne on it. And so to make that, I just used a pretty basic alkane to start here. And then we go through a couple steps. We had Br, and then reduce, and then Br again to create this alkyne right here, and then we attach the Cl at the end with light. And again, I don't think it would go here, but I'm pretty sure this is the spot now. So anyway, once we've created that, we can add these together, and we get this little guy right there that attaches onto this OH, because I think the OH goes to this. Anyway, so sorry. So then from there, as you suggested, I add the Cl2, so we have this little thing right there adding onto the alkyne. And from there, it's pretty straightforward. We just add the OH to switch out one, and then the isopropylamine to take off the other, and there we are at our final project, final molecule. I'm not exactly sure how this mechanism works, but I believe it would in the end work, and just be able to switch with that Cl right there and get us our acebutolol. So that's pretty much all. I had quite a few ideas, as you can see, and some revisions here that maybe you don't see, but in the end I think we got a pretty good synthesis route. It may be a bit wasteful in certain spots where especially the directing of the addition may be more or less random and not too controllable, but in those cases we'll just have to create more and hope for the best in the end. So thank you all for watching, and it's been my final project.